For vectors in one dimension, I'm going to assume my one dimension is a line. If it's a line, then I can put a coordinate system along that line. In that coordinate system, which I'll call x, will have a positive x direction, negative x direction. Here's my origin. So in one dimension, vectors can only point one of two directions. They can point either in the positive x or negative x direction. Let's call this vector A and this vector B. Let's make B a little longer. Vector A will have a magnitude of 2 meters and points in the positive x direction. B will have a magnitude of 3 meters, negative x direction. If I now do A plus B is equal to C, I'll do the tail to tip method, bring the tail of A to the tail of B to the tip of A, and then draw it. The resulting vector from the tail of A to the tip of B will be that. And so C then will have a magnitude of 1 meter and points in the negative x direction. Let's say I want to do A minus B. To do that, I need to find minus B, which is negative 1 times B, which is just B flipped in the opposite direction. Minus B has a magnitude of 3 meters and points in the positive x direction. So now if I want to add them using the tail to tip method again, I would bring the tail of negative B vector to the tip of A, and then the resulting vector from the tail of A to the tip of B. If we call that vector D, D is going to have a magnitude of 5 meters and point in the positive x direction. And so finally, if we do B minus A, I need to find minus A, which is negative 1 times the vector A, just 2 meters in the minus x direction. Then if I were to do the tail to tip method again, the tail of A on the tip of B, the resulting vector from the tail of B to the tip of A, and I see that that vector we'll call E has a magnitude of 5 meters and it is in the negative x direction. All right, maybe that was all too much. We are now going to make working in one dimension a whole lot easier using a new notation. You notice how I was trying to be careful to have the magnitude in orange here and the directions of the vectors in green. So in my new notation, I'm just going to write the magnitude. A is equal to 2 meters. And then I'm going to use the sign up front to set the direction. So the vector A has a magnitude 2 meters and it points in the positive x direction. My vector B has a magnitude 3 meters. My underline looks like a minus sign. I'm not going to do that. Has a magnitude of 3 meters and it points in the negative x direction. I just write the magnitude and I use a plus or minus sign to determine the directions. All the vector arithmetic works just like scalar arithmetic. C, which is equal to A plus B, is equal to negative 1 meter. I just add 2 and 3 together. D, which was A minus B, is equal to plus 2 meters minus a minus 3 meters is equal to positive 5 meters. And my vector E, which is B minus A, is equal to minus 3 meters minus a minus 2 meters is equal to negative 5 meters. So the arithmetic becomes really easy in one dimension. The problem, however, is that now these look exactly like scalars, but they are not scalars, they are vectors. The C is a vector. It has a magnitude of 5 meters and a direction along the positive x-axis. Well, C was negative 1, sorry. D was positive 5. And the vector E has a magnitude of 5 meters and a direction along the negative x-axis. As long as you're always sure that these are vectors and you remind yourself that they're vectors, this compact notation makes working with vectors in one dimension much simpler.